Quick heads up about this episode before we get into it. This was not recorded at the usual setup with Stefan and myself, but it was just me with Sanjay from E3D and RichRap, aka Richard Horne. We talk about some really interesting stuff, like whether you should buy a 3D printer kit or you should source everything yourself, what materials you should use for which purposes. But, and that's a really big but, I did end up screwing up the audio quality. So this episode doesn't sound anywhere close to what I would have liked it to sound. So give it a try, see for yourself if you can actually listen to it or if it's too bad for your ears. If it is, sorry, skip this episode, come back the next one where it's going to be Stefan and myself again at the usual setup. So yeah, let's get going with the show. Welcome to the Meltzone Podcast. Again, it is today October 19th, 2018, and as you may be able to tell, we're not at the usual set. So first podcast with guests. Who are you guys?
Hi, I'm Richard, known as RichRap in the 3D community, and do a lot of work with 3D printing and trained as an electronics engineer.
And I'm Sanjay Mortimer. I am the commercial director of E3D Online. We make hot ends, nozzles, extruders, whatever you want to call them, and early RichRap 3D printing enthusiasts.
Cool. So we know who you are. What are you up to? Like, what's the right now? What are you working on? What are you passionate about? What's going on?
I'll start. Okay, so this year's been a bit up and down for me, a bit of a roller coaster year with time for 3D printing, but I have managed to do a lot more fun things for myself rather than actually focus on content creation. I still find the joy of 3D printing and making fun. So there's been a lot of practical 3D printing around the house, but also some really nice projects to test some boundaries of 3D printing, so with different materials, and that's been really good fun, really. But yeah, tiny things, been printing lots of tiny things using small nozzles, and just figuring out what plastics work with small nozzles. You gave me some great hints, Sanjay.
Yeah.
And so that's been quite fun, and I've really enjoyed doing that, just for myself, nothing to do with blogs or video posts or anything, but yeah, just enjoying doing that. So yeah, that's sort of what I've been doing this year, really.
That's kind of what you've always been doing, kind of pushing the limits and showing what can be done, just of good-looking stuff and really appealing prints, right?
Yeah, definitely. I like to try and get the most appropriate use of material in whatever I'm doing, and some of the practical 3D printing enclosures for electronics. That's sort of my day job, but it's been quite interesting actually trying to use more appropriate materials for certain projects for their material strengths, and using a lot of those little metal inserts that you push in.
Yeah,
they're fantastic.
For the inserts and stuff.
I found joy in using those, and yeah, I've been doing a lot with them. So yeah.
So what have you been up to?
Tool changing is obviously a big part of it, but I suppose to go away from just like the E3D commercial stuff, my like little personal pet projects have been working with Rory we really want to do like a metrology head for the 3D printer that uses the kinematic coupling as the deflection sensor, and so we've got some bits in from Renishaw, so we've got like actual Ruby touch probes and things like that, and so that's like a little passion project that probably doesn't have much commercial output, at least not yet, because it requires a bunch of custom electronics to get made and things. Been playing a lot with making hot ends from scratch again, which feels like going back 5-6 years ago.
Yeah, at least. I still remember, the copper or heater wire wound around stuff.
Absolutely. So it's kind of going back to building your own heater, building that around a nozzle and doing all these things and kind of just playing and exploring by hand to figure out the best way to do that, with a view to, I don't know, maybe doing it in the future for like next generation E3D hot ends. But it's been fun because it's like doing that, but with all the technical resources that we have at E3D. So it's like back when I was like, it's the same kind of joy as back when I was in the like school workshop, like building these little hot ends, but now I have like a machine shop, and I can call up like technical ceramics companies and be like, yeah, with this company we do this and we sell these many hot ends and we want to build like heaters and stuff like that. They'll send you samples out the wazoo, so you can get all the cool stuff. And so you've got like these high-end like technical ceramics. And one of the cool things that's been recent is the whole e-cigarette industry has blown up the market for like custom heater wire, like the nichrome wire. But it's not just nichrome; they've got like nichrome and canthal, and they've got stainlesses and like every single like heater wire you can imagine, heater ribbon, and you can buy all of this on Amazon Prime for these people that wind their own coils. I don't really get it, but anyway, there's lots of heating element stuff out there you can now buy. And so that's been really cool to like slap that on and play with that whole affair. It's been a good laugh.
All right, so Sanjay, as expected, is playing with hot ends.
Yeah, but hot ends is you never known before.
Yeah. It's good stuff. It's good stuff. I mean, we're going
like a one-trick pony.
We're going full circle.
So
yeah.
Like, you do 3D, you do a podcast, you get hot ends.
You have got another focus now with the tool changer and the limitations as well as the possibilities.
Yeah.
I think that's for me. You did remind me there. I have also been clearing the decks to spend more time on tool changers and that sort of ecosystem. So for me, the next 6 months will be very much focused on tool changing technologies.
That's cool. Yeah. That's exciting. We'll have to get you some tool changing bits and bobbin.
Cool, good stuff. What have I been working on? Well, I've mostly been just touring the UK and touring some really interesting places. So I did end up here at E3D. So this has been my last 2 days now. I've been to Adrian Bauer, the inventor of RichRap, the guy who put the idea out, who put the spark out and developed the very first machines, and that is of course working for the RichRap documentary, working towards having something to show to people to teach them on. Okay, this is why we have all these machines that we have now. So Adrian Bauer, I've talked to Gina Heuske from Octoprint about what she's up to, and also about how software plays into things. And I got to see MCPP, so formerly Dutch Filament, one of the world's largest filament manufacturers, and they're crazy. They've got 14 running filament production lines. We're building up to 16 now, and it's a massive operation what they've got going on. So that was good fun. That was my last week basically. And final goal was to see Adrian Bauer. And tomorrow I'm heading home.
Sounds like a busy week.
All day of driving. Oh, it's been good fun. Yeah, they're not often these opportunities where you get to see so many things at the same time. It's been fantastic. Yeah.
I think it's great actually that you got on and done some work on the RichRap documentary. A lot of people are talking about it for years. It's not just a recent thing. So.
Like in 2014 or 2015, Brooke Drum actually put that idea out, and we almost got it to a point where I think I offered to film that even. But I didn't have the knowledge of tools back then. I probably still don't. Honestly, I still don't know what I'm doing for most of the time. But
it's a monster of a project. It's like so undefined because of just like the RichRap project. So undefined and webby. It's like who do you include? Who do you not include? You don't want to offend.
Yeah,
and are
you trying to capture the history or the sort of emotion or the essence or the movement? Or are you trying to capture that?
Again, the goal is to be able to explain to people why, and how RichRap kind of got started and how it went into 3D printing as we have it today. So that's mostly just an educational piece, but also, of course, it goes into kind of the ideologies that the project was started or wasn't started with, as we'll actually find out, kind of how the community works together and all those little bits and pieces that played into where we are now. So
it's a fantastically organic project, I think, which is allowed to grow in all sorts of areas.
Yeah, I'm sure I've missed a lot of details and a lot of people to talk to. I've for sure missed a few of the key early inventors and designers, but you got to say, okay, that this is enough at some point. It's just so much to cover.
Version 2, there always is. That's the whole point of the evolving RichRap. So
yeah.
There you go. Version 2.
Sure. And I guess one more bit of news that One bit of news that kind of ties on to what we've been covering in the last podcast is the entire story with Murph 2019, with CME, CNC, and a few people kind of having a bit of toxic fallout, I guess. That's all been resolved. I don't know how much of that has actually been resolved behind the scenes, but there is going to be an MRF Murph 2019, and there's official dates now, so it's going to be March 29th. That's Friday till Sunday, March 31st. 2019 tickets are on sale, so
We'll be there for sure.
E3D will be there. Rich, you going to be there?
I'm going to make a very, very, very concerted effort to be there this time because I've not gone to one and I really want to go. So yeah, I have been saving, I have been planning, and yes, I do want to go.
It is a. Have you been there before?
I've not. No, I've not been.
Oh God,
I've not been
you're
to
missing out.
That particular place in the world, but
It's right up your street as well. It's like
Very much
I've heard
so.
wonderful things. So yeah.
I'm gonna try very hard to be there. It's. I mean, I've been there last year for the very first time, and it's been good fun.
You did say you thought it was one of the best you visited.
Yeah, it's like it so accurately represents just the core of what is really the community. Yeah, sure that there's trade shows and stuff, but that's companies that are trying to sell you stuff. But Murph is really people working together and developing stuff and showing what they're working on. Yeah. That is really good to see.
Yeah, very happy that it's going ahead, and that I wasn't following any of the I don't know,
Controversies,
micro drama, micro internet drama. But very happy that it's all ironed out. It seems like it is, and that the two parties are like working together. Which is great.
For the good of everyone.
Yeah.
That's fantastic.
That's good to see. Yes, should we move on to the topics for this week? Not recurring topics, but the recurring segments. So I guess I left this out at the beginning of this podcast, and I might edit this back. But for this or that, we're going to have kits or DIY printers. We're going to have the topic of the week, which materials for which applications. And we're going to start out with the this or that. So, Sanjay, I'm going to start with you. Would you recommend, or under which conditions would you recommend for someone to source a 3D printer kit from scratch and build that, or have them buy a kit and
I think
skip
if
the
you
package?
have to ask yourself that question, the answer is probably that you should get a kit.
Really? If you have to ask yourself that question.
If you're unsure in any way, you should probably get a kit.
Okay.
Right? Unless you have absolute confidence in your ability or the necessity for you might need to, well, there are two reasons to self-source. One is in order to achieve your goals, kit printer isn't going to do it. You need to do X, Y, Z, and you're sufficiently competent and confident in your abilities to achieve that you go and you source your own kit and you do it. Number two is that you want to do it entirely as a learning exercise, and once again, you're 100% confident in your ability to resolve that to a working printer, and your motivations are that you want to learn or that you want to achieve something otherwise impossible, because a kit will be cheaper and kind of easier in almost all situations that I can think of, as far as I know. And so I think that, you have to have absolute confidence in your ability to take all these suppliers and turn them into the correct parts, and then turn those correct parts that you've then ordered into a functioning printer.
I guess my surprise and to that reaction is really, wouldn't you just recommend they bought a complete finished machine rather than buying a kit? If you ask that question, if you're asking that question, why are you asking that question?
Yeah, it was.
The marketplace, or because actually the right answer might be you don't want to buy a kit or you don't want to self-source, you want to buy a printer.
Yeah, but I think there's a very valuable lesson in building a 3D printer yourself, even if it's just from a kit, from components that you get laid out and you get a manual with that. It's you understand the workings of the machine, you understand how everything ties together, and if you run into an issue later on, you're going to be very well prepared in resolving that. Versus if you just have the finished machine, you might not even get the results you want out of the box, and you have no way of quantifying what that is, or where that stems from. So it's
And I suppose even if your objective is to make a machine that the kit doesn't do, you want to do something advanced. I don't know, make a high temperature machine. then building the kit first will put you in good, if you're unsure about your ability to do the self-source thing, do the kit thing, and then you'll be put in good stead to modify that machine and build it into whatever you want it to be.
Yeah. And you mentioned cost for kit versus self-sourcing, and I've experienced that in the past with the RichRap, the Dolly project, Dolly i3, kind of trying to clone the Prusa Mark II, which is functionally similar, not identical, but similar to what the Prusa Mark II does, and it ended up costing more than Sorry, should have muted my phone. It ended up costing, well, not more than the real deal, but it ended up costing more than cheap printer kits. And it used all the cheap parts. So you kind of get the equivalent in component quality. Sorry. But you spend a lot more time on sourcing everything and on just trying to make stuff work versus actually getting to use the machine and tune it. Whereas with a kit, you just get the thing and you at least know what to expect.
I generally couldn't agree more. I'm sort of playing devil's advocate because everything I tend to build is either from scratch or from kits, and my kids have done the same. They've only had 3D printers that have been built up as an occasional usage. The ones they actually use day to day and the ones they're building now are all from kits. So my youngest daughter is building up I made 3D jelly box at the moment, which we saw them at the TCT show, and that's a fantastic kit. Everything is labelled better than a Prusa i3, and the manual and the instructions are even better. So it really is fantastic for kids to do that, and they get all the tools and everything else. So and it's fairly simple because most of it is with tie wraps. So you build everything, the construction with tie wraps. But yeah, both my kids have built Prusa i3s from kit. So yeah, that's been a good learning experience.
Yeah, so I mean, there's not just one type of kit, and there's not just one type. Well, self-sources is going to be a pain either way, and there's also not just one type of already built machine, right? There's different. For the same user, you might be able to recommend different kind of brackets of either a kit or a finished machine.
Yeah, I guess maybe the question, if someone is asking if they should self-source, is because actually they are interested in innovating and doing something different. Maybe they're not happy with the kits that are out there or the machines out there. So you can take the opposite view that actually this person could be completely competent, and buying self-sourcing could be part of that whole strategy of them learning as well.
Absolutely.
And there's always the option that they're just a masochist and just like I need the experience of sourcing and building everything myself, and that can be a learning experience,
And I think you're right. It can cost almost as much, if not more sometimes. I've done the same exercise and thought, well, actually, this kit, they're making a decent margin on it, but doing it all yourself is perhaps not such a good idea.
Exactly. Yeah. Cool. So overall, self-sourcing for the hardcore. Yeah.
I think so, unless you've got a real reason, or you want
to
sell kits.
And do a kit as well. Our first printer was a kit, and then after we used the kit to learn, then we went on and self-sourced, and the machines are there. That's my first kit, and that's my first 3D printer. Self-sourced. So.
And of course, the big box was probably the ultimate kit.
Yes, the ultimate.
Well, it's self-sourced, I guess. Yeah.
You rank printers by. Best printer has the most fastness.
Ultimate amount of investment of time.
We had the most fastness.
I think he's still getting beat up by the salesman.
Yeah.
We counted it was over 1,000 fastener bits.
Yeah, there was a lot of bearings in that, wasn't there?
Bearings and washers and everything's a bolt, washer, nut, piece, washer, nut.
Ooh, perfect engineering.
Yeah.
And the rules a bit.
Yeah, and then Prusa came along and just
followed the rules.
Yeah, but
make it work.
But that's history, and I feel like we're way past that.
Yeah,
for most bits. All right, we're making good time here. I think we can move on for the big topic. What materials? We have two material specialists here, I guess.
I wouldn't call myself a specialist. I just enjoy playing with.
I just vote plastic enthusiast. I suppose to qualify that, neither of us have any formal materials background.
Yes, but both of you are into materials and playing with them and trying to make the best of what's available.
I think real world experience from my day job in electronics and interaction with materials and products and the approvals and regulations that go into some of those things give you an idea of the sort of materials that you use in industry, and then the exciting different materials that you can use in 3D printing. I think you mentioned polypropylene in previous podcast, and that's
and Stefan's really into that.
And that's really interesting because it's a fantastic material and it's been particularly difficult to print with. Back in the early days,
amazed that anyone got any polyolefin to print ever.
Absolutely, and then I always just thought, you got no chance. But it's starting to formulate into a sensible product that you can actually 3D print.
And so supposedly it is very easy to print and gets massive layer adhesion.
And that's fantastic. That's actually, I spend most of my time, the first time I use a new material or a new source or a new manufacturer, if I know that they're trying something different, it's layer bonding. I'm playing around with layer bonding. I don't really care about the quality or the finish or anything until the layer bonding's been proven to be sensible.
It's kind of that trade-off point where you tune it temperature and print settings wise to have good layer bonding, and you can work from that, because that's kind of the sweet spot for a material. When you figure out, okay, this sticks, this makes a mechanically sound part, that's kind of when I feel this is how the material wants or needs to be printed.
Yeah, definitely.
So that's PP, and that's probably the most exotic one so far, and the one that we're starting out. So does PLA actually have real-world use cases beyond just being pretty and being available in all sorts of different shapes and sizes and forms?
I think people are always like, PLA is weak, but if you actually go and...
It's very strong.
Yeah,
it's like, it can be like glass. It's really,
If you go along and actually look at the stats, PLA is stronger than ABS, just to really cull that myth right at the start. PLA is a very strong material with an amazing flexural modulus. It's very stiff. And it's very dimensionally stable when you print it. So it's actually fantastic for mechanical parts. You can print it super accurately. You get very rigid, very stiff parts that are also very strong. But let's also talk honestly about the downsides. It has a brittle failure mode, so it doesn't have much toughness, and it's not great at the extremes of temperature. So when it's cold, it becomes even brittler, and when it's hot above 60, it's a waste of time. But if it's a room temperature component, that even if it needs to be quite strong, PLA is probably your best bet. Don't discount it. I think people throw PLA away and go, I'm going to move to PETG and it'll be stronger. Well, actually, overall, your holistic experience, the quality of the part that you can produce, how dry is your PET compared to how strong is your PLA. Don't discount PLA. Think about your application.
I mean, I've done I don't want to say informal testing, but the comparative testing of PLA against ABS, against PETG, a ton of filaments, and PLA very much is a strong filament. But you mentioned temperature. There's also the problem of creep over time. If you have it under tension from a fastener or something, it will give, and that fastener is going to come loose. And also from the early printer builds, I remember, I'm not sure if it's still the same PLA we're using today, but if you had, for example, the Mendel top profiles where it held the Z-rods, those would crack over time if it was just PLA. So for anything that is like under constant stress, it's probably not the best material to use.
No, it's not. I think if you take all those downsides, the upsides are always that it's very, very easy to use on most
the overriding
printers. Yeah, definitely. And I think it's still a wonderful prototyping plastic. And I don't mean to sound negative on it, but it's just a very easy way. You're not going to get too much warp on whatever size objects you print. You can figure out whether or not you can print those in other materials later on. But if you want to physically test something, that's fantastic for PLA. So I wish it had more layer bonding like PETG and a bit more impact resistance. Maybe some blends and mixes we'll see in the future may allow some.
There are some materials that do a bit more impact resistance, but at the expense of rigidity, stiffness, and also overall strength. So
You don't get something for nothing in the world of PLA. Like,
Absolutely.
your additive, your tougheners make it, less stiff and so on and so forth.
So is there even a place for an ABS? As you mentioned, it's weaker than PLA, which I can agree. But is there a place where ABS or PC ABS or blends of that make sense?
I think so, in some small cases. I think that for like testing, it can be really good. But ABS also does have some quite nice properties when you're printing it. Like, yes, ABS can be a real pain when you print it, but you can get ABSs with fantastic flow properties, and they have this peculiar characteristic where they can be extremely flowy and runny when they're in the flowing state, but even when it's hot, if it's not under any stress, they behave as a solid. They call a whole class of fluids called Filament plastics, which mean that you can very easily pump it through a very small nozzle and highish flow rates, and you can get it to go into place very easily. But as soon as the nozzle leaves where it is, it behaves like a solid. So you can get these fantastic overhangs. It's one of the very high flow ABSs like MG94 and high flow ASAs that are used in making these big thin walled components. Like they're designed for molding like TV screen bezels and stuff like that. You can get them to flow through tiny nozzles, form into really fine features with a lot of crisp definition and accuracy. And you can of course use them to simulate ABS parts in certain ways within certain use cases.
I think as long as you keep ABS parts relatively small, and with those smaller nozzles, you can get some incredibly good quality prints out of them. So I think ABS still has a very good usage, but it's generally we're seeing less of it being used for larger parts, or even by industrial customers. They realise that actually it's not just ABS. Just because they used to use that in injection molding and they're used to that for prototyping, it doesn't have to be for their 3D printed part.
Yeah,
it's also a material that machines quite well afterwards. Tap or post.
Doesn't squeak like P2G or melt like PLA.
Yeah.
But I gotta say, I actually like printing PC ABS or even good PC by itself a lot for anything that is in contact with heat rays outside or might be in the sun. I mean, PLA, of course, as soon as it sees sunlight or is out in the car somewhere, it's just over. It melts, it's soft, it deforms, it crystallizes maybe even. And that is, I mean, PLA shrinks a lot if it does that. But that's also something that I've noticed with some PETGs. If you leave them out in the sun and they get to a certain temperature for a while, they crystallize, they might shrink a bit, but some also become brittle. And I've run into that before, and it's a huge problem. If you use a part and you take it straight off the printer, it works. Then after a week or two, or you have a warmer day in summer, it all of a sudden is a completely different part. And something like an ABS or a PC ABS does not do that. So you get it off the printer, that's exactly the part you're going to have for the rest of the part's life.
Yeah, there's something about a PC that I've never and this is really hard to describe, but anyone that's stared at plastic coming out of nozzles and laying down into beads for long enough, probably like Rich and I have, and you as well, there's something indescribable about PC and the way it lays down and seems to just lay into these just gorgeous, perfect, translucent layers with that full interlayer, optical transparency, and there's just something really fantastic about PC and the way it prints. It's a pity that it needs those higher temperatures. There's been some great work done on that on the PC Max by Polymaker, and those is a really fantastic material. But really, they're kind of back blending it with lower end polyesters and copolyesters like PET and the like to achieve that. Still a fantastic material, but it loses some of that that PC glory that I really miss.
But it does make it fantastically easier to use and much more accessible. I think that's the interesting thing with all this talk about materials and the different resins, because there's thousands and thousands of different mixes. And that was also my experience with PLA and small nozzles. Pretty disastrous, but actually the Polymaker PLA Max, Polymax, PLA ran really, really well. It behaved almost like an ABS and was the only part I could use that wasn't ABS or other blends to use in really tiny, small nozzles. And you still get good layer bonding, and you still don't get that shattering of parts later on. So I think that's a good compromise. But that probably should be encouraged. People get a little bit carried away with additives and modifiers and not being pure to the resin, but I think actually fine. It's good to mix these blends up a bit. And,
to make them printable.
3D printing. It's a different discipline after all. It's not injection molding. It's not all of these other things. So
what we're seeing is that like this progression. Like we started off with, we would go and we would read all the data sheets of the available resins and pick an injection molding resin that would work, and then the extruder companies would buy that, extrude it into a filament. Hooray, you've got an acceptable material. And then came the like, right, well, let's add some plasticizer or adhesion modifier to make it stick to the bed better or make it flow more easily. And so the compounds and the compounders, and I think that's kind of where we were a year or so ago. But now I think we're starting to see the first fruit of chemical companies, big chemical companies, actually synthesizing and building the molecules for such that, you know, there's only so far you can go with compounding. You're taking an existing product, you're mixing it up. You know, you can't mix together, you know, orange juice and apple juice and get Coca-Cola. Like we're actually producing these chemicals from scratch, and you can construct the chain as you want it. And we've been playing this game with the peak that we're working on, and we can call up the company and say we want the chains a little bit longer, and we want a little bit more of this in here and that on there, and so on and so forth. And that'll happen. And there's been great work by Eastman on the kind of Amphora range and the NGen stuff. That's one of the very few. I think Steve Wright over there was one of the pioneers in doing this. And I'm just really excited for now that we're getting, you know, Mitsubishi coming in and having a presence in the filament world.
They've been there before. Verbatim is Mitsubishi as well.
But as far as I know, all of those materials that they're doing are not like synthed by Mitsubishi from scratch yet for FDM. But I'm super excited to see what comes next, because if we can take PEEK and make it printable without a heated chamber, like what can you do with polycarbonate, or what can you do, you know, with things like you know, polypropylene? We can get these, you know, I'm hoping that soon we'll get Delrin and acetyl in a printable format.
Wow.
Like, that would be incredible. That's completely unachievable with current Delrin resins because of their shrink rate and their crystallinity. It's not possible. But it's a super high performance polymer that's used all over engineering. It's completely unprintable to us right now. And I think it would be like the advent of nylon all over again.
So one thing I've been wondering is why we haven't seen more of the phase change process in 3D printing. So the actual change of amorphous or crystalline structures. It's getting a little bit heavy now, but it would be really interesting to see whether or not that type of process could be more slickly integrated into the 3D printing process, and actually sort of you know, what materials may be available to us then.
Yeah, so for the listeners here, just to explain that idea a bit more, it's something that, for example, has been known from protopasta with our HDPLA. You print the part, it's amorphous. When it comes off the printer, the polymer chains are not in an orderly fashion, basically. Please correct me if I get anything of this wrong. So the polymer chains are kind of chaotic, and it's typically the it's a clear filament if it's glossy kind of, and then you heat it up to a certain critical temperature. You keep it there for a while, and the polymer chains arrange themselves in a nice regular structure, and that drastically changes the way the polymer behaves, or the plastic behaves as an entire thing. And you can do that to 3D printed parts. Some of them might shrink a bit, some of them might, you know, become unusable in some way, but with some polymers, it just turns them into this massively overperforming thing that you didn't have before. For example, with PLAs, all of a sudden it is more rigid, it is stronger overall, it is temperature resistant like nothing else, and it's an amazing process. So why is that we're not seeing more of it?
I think the one thing, the way you described that, the NatureWorks resin that's used in that high temperature PLA and the process to anneal afterwards is a fairly straightforward process that anyone could do with a fairly well temperature controlled oven. I think maybe Sanjay, you'll have a bit of an idea on some of the other materials that you often have to cook in oil for a huge long period of time and slowly heat them.
I've not actually heard of that.
Yeah, so some materials, to change their state, you do have to do some crazy things and over a very long period of time. So I think that's maybe why we haven't seen so much advancement. But I do wonder whether there's any easy wins like the high temperature PLAs we've seen recently.
Also, I think that the part of the reason here is that post facto crystallization of parts is relatively unexplored in industry. So, for example, with PETs, high-end engineering PETs that you use in automotive, they're designed to be crystalline, supercrystalline, and so you heat them up molten, fire them into the mold, and then you let them cool slow enough, and you make the mixture, the chemicals, their like inherent properties want to crystallize faster, and then the part pops out supercrystalline, hooray. And or you make a bottle and you pump it out and use a resin that's more amorphous, and you cool it down quickly, and it goes in the amorphous state. And so resins have broadly been in those kind of two categories, amorphous or crystalline, and intentionally placed in those two. And once the part's formed, you don't tend to take something in the amorphous state and turn it crystalline in industry beforehand. So in order to do this really well, you need to create a resin that is quite amorphous and is amorphous enough for you to print it and manage the printing conditions and keep it amorphous, and then still be easily crystallizable. And because industry has been in we'll have a crystalline version or we'll have an amorphous version, you've got resins that are kind of at either end, and you don't have this kind of little bit in the middle. So we end up doing things like taking nylon and then printing it with the fans on full to make it print amorphous, and then sometimes take it and then crystallize it afterwards under conditions there. So I think that like that whole post-facto crystallization of parts is something that industry hasn't fully explored. There's some fundamental science still to do, like formalization and synthesis of polymers. I don't know, we're getting pretty heavy into the weeds with chains.
Yeah, but it's fun stuff, yeah.
I think some of it comes back to the hot end as well, in what's actually possible to do in that with the materials. I've certainly had some PET that behaved incredibly oddly in a hot end at certain temperatures, i.e. becoming a crystalline block and then having to be
clogging out the hot end.
And clogging out, what I'm talking about.
Yeah,
and
we've
done some work.
And
I had a lot of, I would say fun, because it was fun. I knew what was going on, but it would be incredibly frustrating for anyone who bought that material, put it in their hot end and ran it at 265 and thinking, well, I should pump it through. Actually, that's exactly the wrong temperature to run it at, and you have to pump it up to 290 almost to get it to flow again. So it's a weird material, and I thought it was great fun playing with that, but someone who bought that material, just expecting it to work, would have an enormously bad time and probably blame your hot end, I would have thought.
Yeah, I imagine so.
Yeah, but overall, I mean, not a lot of people are using that process intentionally and are crystallizing their parts once they come off the printer. And I think that's just because it's an extra step. As with anything, people are lazy. They would rather have something that they can grab off of their printer and have it perform exactly the way they want, versus maybe even needing an extra device, an extra toaster oven that has been modified in some way to do the temperature curve.
Unpredictability, right? The parts necessarily change temperature when they crystallize. That's a physical thing that has to happen when you crystallize a part. So they will change shape, and how they're going to change shape is unintuitive and unpredictable.
I guess we've seen that recently in some of the metal machines that are taking green parts and shrinking them. You're seeing the same sort of process happening. There has to be a controlled shrinkage, and that's a very, very difficult thing
I think those guys have it much easier, right?
Yeah, okay.
Yeah, because sintering is a process Sintering is a process, as I don't know much about sintering, but as I understand, it's much more isotropic, whereas polymers shrink because the chains align when you put them down, particularly in FDM, the chains align perpendicular to the flow. So in the kind of the radial direction, you get more shrink because all the chains are like this, and then they go thunk and snap together parallel, and you get less shrink in the axial direction, which was backwards to how I imagined it to be.
I can see that.
It's kind of like wood, right?
Yeah, it's just like wood. Yeah, just like wood.
Okay. I guess the other thing is we've just talked about FDM. There are lots of other materials in 3D printing as well.
True. I don't have a ton of experience with resins, to be honest.
Well, I don't particularly like resins. I've used them and don't particularly get on with them. But paste, I think there's a huge amount of usage that we could use in 3D printing with different pastes. And I think that's only just been touched on. And people have done the usual sort of standard ones. But integrating that. And that's one of the tool changer aspects that I think where they will start to see some really interesting uses of paste, even if it's to add a silicon seal on afterwards, silicon seal or something on a 3D printed part. Something as simple as that, but that can be a really interesting aspect to that side, where you just can't get that from thermoplastic materials. So I think pastes have a long way.
Yeah, and with paste you can do more than just polymers, you can do more than just plastics. I've talked to the guys at Buccosini who are printing foodstuffs. They're printing, potato, whatever that is.
Anything you can mush,
potato,
really,
mashed potato. They've been printing liver pate and all sorts of weird stuff. Honestly, I don't much see the application of that, but where I do see the application, it's kind of a gimmick.
The best application I heard for 3D printing food was for care homes. So you can recreate a carrot, but it isn't as difficult to eat as a carrot.
Yeah.
It's still got some bite. It's still got some.
Cute. Yeah.
It still looks and feels like a carrot. It's not just a plate of mush, but actually you can break it up quite easily with a spoon. So I think
honestly, wouldn't it just be easier to make like a vacuum formed mold and just spread your paste in there? You get a much nicer result, and it takes seconds instead of hours to print.
Maybe, yeah. And I think it's back to will it be appealing to a very small minority who's quite happy to pay for that customer experience? Now that's usually how these things get driven from Michelin star chefs.
Yeah, like customized cakes and stuff. Yeah.
But I would love to see actually that technology, whether it is 3D printing or mold making or whatever else, be used for the aging population. I think that's actually a really valid usage case for the materials and 3D positioning systems.
Yeah, so food and also what you can do with paste is you can do ceramics. Yeah. There have been some incredibly awesome demos and showpieces of how we can use a ceramic clay kind of material and print it. It stays in shape. It's printable like a filament. Then you fire it and you have your fully functional, still 3D print looking parts, but you have a fully functional ceramic part all of a sudden. And what was it? That was at the Bay Area Maker Faire. There was a project that was kind of repopulating, that's the word, coral reefs. So they made like substitute reef structures basically. Dumped them into the ocean and watched the reef grow back basically.
That was one of the very early. That was like 2011. People were doing that in Sydney. So that was one of the very early usage cases for concrete.
Okay.
Well, it wasn't concrete printing actually. It was a mix of stone and certain chemicals to reformat the stone back from a paste material. So it wasn't a concrete structure that would be negative to the environment. There was actually a stone-based.
Because there was some inspiration happening there with that.
That's one of the big usage cases for large format 3D printing. So,
Super cool. Yeah, and I guess one of the last materials we could touch on is the ultra high performance stuff. So first of all, carbon filled. I've personally not had good experience with carbon filled materials. Yeah, they look nice. They have a nice texture to them, but very often they're either not putting enough carbon in there or chopping the fibers too short to actually make a noticeable difference in strength. Most materials are going to print better because they don't shrink much, but they're not performing better in the end. Yeah. Have you guys made any different experiences with carbon filaments?
I've had pretty much the same experience, really. It's an aesthetic. I found it to be quite disappointing. There have been some good samples that I've had for stronger carbon fiber materials, but generally I do find that people are charging a lot for effectively something that's just matte and black, and not a huge amount different in there.
I think that we're getting there. I think that some of the new carbon reinforced nylons have valid applications, and we've got to look at why we're adding the carbon. Like why add carbon to a resin? Increase modulus, increase strength, but also decrease shrinkage and warpage. And there's a whole very valid argument that is this will allow us to print higher performance materials more easily. So carbon-filled nylon and carbon-filled polycarbonate are much easier to print than their unfilled relatives in a lot of cases, warp-wise anyway. I think that with material science we can get that increase in modulus I've been able to get materials to show increases in strength and definitely modulus. So I think that a lot more engineering needs to happen, but they have a lot of I think they have a significant future. But I think the big caveat to all of this is I think that glass can do probably 90% of what carbon is doing. And so why are we not using glass? Well, it's because glass tends to be made in larger diameter strands, and carbon tends to come in smaller diameter strands, and the carbon fits through the nozzle easier. And so we pay this huge premium to get a fiber-filled material that is really utilizing none of the exceptional properties of the carbon. So you're paying, you pay the filament premium, you pay the filled filament premium, and then you pay for the carbon as well. And so you end up paying, £50.
And your hardened nozzle and your
hardened nozzle.
So basically what he's
well spent. Yeah, it is. You get to use that forever. That's not a consumable.
So basically what he's saying is if you're using fiber filaments, use a large nozzle and use glass fiber.
No, I'm saying that filament manufacturers should get smaller diameter glass and put it in nylon, and then sell lower cost glass reinforced nylon.
I've tried glass reinforced nylon.
It's
not a nice thing to use at the moment.
But that's because the broken glass.
It actually looks quite knobbly. The filament.
And you run your finger over it, and then you look at your finger and you're like, "Ouch! I'll never do that again."
I had an application I wanted to experiment with to fix a bathroom shower screen. It was a friend of mine, and I knew it was basically glass-filled nylon, the original part. And tried to replicate that and gave up. I ended up using PCABS, and that was fine. It was absolutely strong enough, and it did the job. But it was an interesting experiment to play with that. And I agree with Sanjay. It just needs a little bit more research. But yes, the one of the best PLAs I ever had was just a carbon-filled PLA. It was supposed to be conductive, but it wasn't good enough. But actually, it was a really nice PLA to use and print with.
Yeah, they're super dimensionally stable parts, and I think that you'll probably find that. So ColorFab's got a new nylon out that they announced at TCT. I believe I wasn't there, but they've got a new nylon out, and Polymaker have their new nylon out, and neither of them are advertising them as filled materials, but I have a very strong suspicion that they are using fillers. They're just not fibrous fillers. I think that they're using nanoclay as mineral fillers, which are all over the polymer industry. We use them all the time in polypropylene and things. They reduce cost because they're mainly made of dirt, and dirt is cheaper than plastic. I mean, things don't get much cheaper than dirt.
Clean dirt.
But clean,
clean and sorted.
Dirt. I mean, it's basically you dig it out of the ground, you crush it up, you chuck it in the extruder. But we've been using them for a very long time, so they're very well understood, and they increase stability, slightly increase stiffness, a bunch of other properties, but they massively reduce shrink in 3D printed parts. So again,
interesting,
having these fillers in really intelligent ways, rather than in the past it's just been like carbon is cool and people buy carbon, we'll insert carbon. Now we're starting to get into the intelligent addition of fillers that belong there for specific reasons. So I have faith. I think that no fill materials have not shown their true promise to the FDM world yet, but stick with us, and we'll get there.
We're getting there, yeah.
And do you think there's more options than if for FDM and thermoplastics than there is for resins, for example?
Yes.
Yeah.
We've got a like multi-trillion-dollar head start. 50 years of polymer. Like, it's just a no-brainer. Like,
Yeah.
Thermoplastic is the most widely used material on planet Earth that humankind uses to manufacture the made world around it.
Maybe concrete?
Yeah, in terms of number of parts.
Right. Yeah.
Yeah.
Certainly numbers of unique designs and the like. But it's up there at the very least.
Yeah.
And that it's had some effort put into it. And so I think that yes, if we're looking at what 3D printing will do in the polymer world, it's thermoplastic polymers in the 3D printing world. I think that physics is probably on our side, but also there's a huge head start an industry basis.
Definitely, I definitely agree. I think I'm always surprised when people ask when FDM printers will die or when they will not be the norm.
When SLA will replace.
It really surprised me, and I have to tell them basically the same sort of thing, that they both have a purpose, but actually the reason why it's been around for 30 years already is still because it's still a very valid process.
I must say that Carbon are doing some really cool. A lot of people
Carbon
see
3D,
Carbon and they're just like, oh, they're the people with the cool.
Yeah, it's just a
zippy
fast
up
printer, but actually
no.
the chemistry there is.
The chemistry, it's really cool. So
Yeah.
they mix the light resin with the thermoset resin. It's freaking neat.
Yeah.
That's on the cutting edge of resin. I think for most makers, you're going to be stuck to fairly bland formulas for some time in resin, whereas FDM is going places.
Yeah. So I think with SLA resins, there's because as you mentioned, FDM and polymers, injection molding polymers, have seen so much research already. I think there's a ton of untapped potential with SLA because we've just not seen the full spectrum of what's possible and what might still be out there. So then, as soon as there's a bit of interest there, I'm sure that there's going to be new developments that do more than what we think we can do today. Just how science works, right?
Yeah. There's definitely a lot more to come. I just would preface that with, I think it's harder to get things to polymerize with the addition of a photon and then get all the molecules to couple together than I think it is to have molecules that already exist and are synthesized just jumble themselves around a bit. One is an inherently more complex, more difficult process than the other. And I think that adds quite a bit of constraint to your available chemistries and properties.
And certainly from the accessibility side, it's still going to be easier to run it on a real through a 3D printer in a thermoplastic system than it is any other type of resin.
Yeah. All right. Good stuff. We're not going to do Q&A today because we are running out of time. Yeah, well, it's all right. But I think we've got a good hour of very interesting content and good stuff we talked about. So thank you.
No, not too much about
Hey, but that's what this podcast is for, right?
It's all about the Meltzone.
We get an hour to just talk about the stuff we enjoy, and I think we've done that. So thank you both for being here, and thanks for spending the time.
Thank you.
It's been great.